Hello everyone. In this video we're going to be talking about how to balance chemical equations, and hopefully by the end of the tutorial you'll feel more confident when it comes to tackling a chemical equation. I'll try to break it down for you and I'll discuss different types of equations, and over here on the left hand side, as you can see, I've listed some equations that I will be discussing, so let's get right into it. So let's start with the very first one, which is a very common equation, and hopefully you will all be familiar with it if you've been studying chemistry or biology for a significant amount of time. So over here on the left hand side we have CO2 plus H2O, which give us C6H12O6 plus O2. Now this is the very famous photosynthesis equation, and in it we have carbon dioxide reacting with water, and they both react together to give us glucose and oxygen. Now on the front of it, this equation kind of looks challenging because we have big numbers on the right hand side, but let me break it down for you. Okay, so the first step to balancing such an equation is we want to look at balancing the elements which appear only once on either side of the equation. Now that would be carbon and hydrogen. So over here we have CO2, and the carbon that reacts over here, it comes back here to give us 6 carbons in the product. So what I'm going to do is I'm going to add a coefficient of 6 here. And then we have hydrogen. So let me just replicate this equation on the bottom just to give us a little more working space, right? So CO2 plus H2O, C6, H12O6 plus O2. Let me make my O proper. Okay. And then just to change the color so the coefficients are more visible. Now we said that we were adding a 6 in front of the carbon dioxide. Now any number that goes before the compound is called a coefficient. So the coefficient of carbon dioxide is 6. Now we want to look at the other element which appears only once, and that would be our hydrogen. So the H2 over here goes to H12 over here. So we can see that the 2 is being multiplied by a factor of 6, so we're going to add another 6 in the front of water. Now the coefficient of water is also 6. Now this makes things a little bit more easier for us because we've balanced the carbons, we've balanced the hydrogens. Let's just do a quick check. So 6 carbons here are giving us 6 carbons here, and 6 times 2, which is 12. 6 hydrogens are giving us 12 hydrogens over here. Now what are we left with? We're left with the oxygen. So over here we have 6 times 2, which is 12, plus 6, which is 18. We have 18 oxygens on the left-hand side. And we only have, on the left-hand side, we have 6 oxygens in the glucose and 2 oxygens by itself. So 6 plus 2 gives us 8. Now what I'm going to do is I'm going to place another 6 over here, just to see if this balances that out. Now what do I have is that 6 times 2, which is 12, plus 6, which gives me 18 oxygens. Let's just do a quick check. So what I'm going to do is I'm going to make a tally table for both sides. This helps if you're a beginner with balancing equations, just to kind of like visualize things for you. Now over here on the left hand side we have 6 carbons, we have 12 hydrogens, and we have 18 oxygens. If we go to the right hand side, we have 6 carbons, we have 12 hydrogens, and we have 18 oxygens. That balances our equation. Now moving on to the next one. So we have over here C4H10 plus O2, which gives us CO2 plus H2O. This is a combustion equation. Now in a combustion equation, the very first step, just like we did previously with the photosynthesis equation, is to try and balance out the elements which only appear once on either side. And what we can do here in the beginning is that we look at the number of carbons, which is 4 on the left-hand side, and we only have 1 carbon on the right-hand side. So just to, again, replicate the equation to give us more working space, C4H10 plus O2 gives us CO2 plus H2O, okay? And then to add the coefficients, when we start by balancing the carbons, we have 4 here and 1 carbon here. So obviously that would give us, we would want to balance it with a 4 here. Now we go to the hydrogens. So we have 10 hydrogens here and 2 here. So to do that, we multiply the 2 by 5. So it's important to remember, this is for the people who are just learning how to balance equations, is that whatever coefficient you have in front of the element or the compound, every element in that compound is multiplied by that coefficient. So if we have H2, that would be multiplied by 5, which would give us H10. Now, if we, what are we left with? We're left with the oxygens. So over here on the left-hand side, we have 2. And then on the right-hand side, let's just do a quick sum. We have 4 times 2, which is 8. And then we have 5, which give us 13. So now we are facing an odd number. What we can do in combustion equations is that just to, as a quick way of solving it, we know that we have 13 oxygens on the left-hand side, and we only have 2 oxygens on the right-hand side. So what we can do is that we can multiply it by a fraction, 13 over 2. Right? So when we would consider how many oxygens we have, if we just look at the fraction, this 2 would be cancelled by this 2 and it would give us 13. But when we look at proper equations, we're not allowed to have fractions in them. So what we have to do is multiply the entire equation by 2. Okay? And so our final equation in this would be, when we're multiplying everything by 2, it's 2C4H10 plus 2 over here would cancel the 2 in the denominator, plus 13O2, which gives us 8, which gives us 8 CO2 plus 10 H2O. Okay? And so now let's just do a quick tally. This should be your practice after you balance equations, just to see if everything adds up. So on the left-hand side, for carbon, hydrogen, and oxygen, for carbon, we have 8 carbons on the left-hand side. We have 10 times 2, which is 20 hydrogens, and 13 times 2, which is 26. And then coming to the right-hand side, carbons, we have 8. Hydrogens, we have 20, and oxygens, we have 16 here, and we have 10 there, which give us a total of 26. So that balances our equation. Now let's move on to the next equation, which is also a combustion equation with C3H8. So what I'll do here is come down to this side, C3H8 plus O2. Combustion equations always give you the same products. They're always going to give you carbon dioxide and water. So at this point, if you want to take a second to yourself or a few minutes, you can feel free to pause the video and try to solve it using how we solved the previous equation, and then you can come back to it if you think you have a solution. Okay, so I'm just gonna move it down here. Now, simply, we need to balance the carbons first. Okay, so we need to balance the carbons, which would give us 3 here, And then I move on to balancing the hydrogens, 8 here, so I need to multiply this by 4. And then 3 times 2 is 6 plus 4, which is 10. Simply, I will add a 5 here. And then just do a quick check. So on the left-hand side, I have 3 carbons. I have 8 hydrogens. I have 10 oxygens. And then similarly, on the right-hand side, I have 3 carbons. I have 10 oxygens. And I have 8 hydrogens, so that balances our equation. Now let's look at the next one. I think it's a metal reaction. Okay, now this is the reaction with, we're looking at number 4 here. So this is the reaction with SiCl4 and water. So now what we want to do is that we want to look at which elements occur only once. And those would be, so when I say once, I'm looking for elements which are only occurring once on either side of the equation. Now that's not really a problem here because as we can see, every element only occurs once on each side of the equation except for hydrogen over here. So what I'm going to do is that I'm going to start with silicon, Si. Now this is easy because over here there's one silicon on the right hand side and only one silicon on the left hand side. So there's not really much work involved. So let's come to chlorine. So we have 4 chlorines on the left hand side. So I'm just going to go ahead and put a 4 here, right? Now my chlorines are balanced. So I have 4 chlorines on the right hand side and then 4 chlorines on the left hand side. Now let's move on to the hydrogens. So I have 2 hydrogens on the left hand side, but on the right hand side I have 4 here and then I have another 4 here, which give me 8. So what I'll do is I'll put a 4 here. Now let's check the oxygens. So 4 oxygens here because it's being multiplied by the coefficient, and then 4 here. So just by balancing the chlorines and the hydrogen, the oxygens balance themselves, which make it pretty easy for us. Now this equation seems a little bit simple when you take a first glance at it, but it requires careful balancing. So I'm just going to replicate it here. Now, what do we have? So on the left-hand side, we have 1 aluminium, which reacts with hydrochloric acid. Also, the elements H and Cl only appear once. And then on the right-hand side, we have one aluminium, we have 3 chlorines, and we have 2 hydrogens. So the way I want to start this is that I want to first balance the odd number. This is a kind of tip that I use to balance equations. I try to go by balancing the odd number first, and it usually eases things out for you. So let's see. What we're basically trying to achieve is to balance both the hydrogens and the chlorine, right? So let's start by putting a 2 here, because this is the lowest number by which I can multiply 3, which is going to make it an even number. Now, on the right-hand side, I have 2 aluminiums and I have 6 chlorines. So what do I want to do? I want to put a 6 here, which is going to give me 6 chlorines and 6 hydrogens. And then let's not forget the 2 for the aluminium, right? And now simply, I need to even out the hydrogens. So 6 hydrogens, what can I multiply 2 by to give me 6? 3, right? An alternative way of balancing this would be if I had, for example, so here I chose to balance the chlorines first, but what you could also do is that you could start by balancing the hydrogens, right? Or you could start by not making the odd number even. I mean, there are multiple ways you can do this equation by. So if I were to tackle this by balancing the hydrogens first, I would add a 2 here, right? And then what I would need to do is find the lowest common multiple between 2 and 3 in order to balance my chlorines, and that would be 6. So I change it to 6, and And over here, what do I need to achieve 6? It's 2. And then over here, what do I need to achieve 6 is 3. And let's not forget the 2 here, right? So this is just a quick 2 methods of balancing equations like this. Now this next equation should come pretty simple, and it should be pretty easy to balance. So if you want to take a minute just to try and attempt it on your own, feel free to pause the video at any moment and solve it and then come back to see how it's solved. I mean, it shouldn't take you more than a minute, right? So in this equation, we have 2 iodines on the left-hand side, 2 fluorines, and then when we come to the right-hand side, we have 1 iodine and we have 7 fluorines. So the iodines seem pretty simple to balance, so let's start by balancing them and putting a 2 here. Now what I have is that I have 2 times 7, I have 14 fluorines, so I'm simply going to put a 7 here, and that balances my equation. Now for this next equation, we have sodium carbonate reacting with hydrochloric acid, and the products are sodium chloride plus water plus carbon dioxide. Again, if you want to solve it on your own and then compare to my solution, please feel free to take a minute and try and solve this. It's better if you get into the practice of solving equations, because ideally practice will make you perfect. So let's start. Let's look at the sodiums. We have 2 sodiums, and then carbons on the left-hand side, we have 1. Oxygens, we have 3. 1 hydrogen, and 1 chlorine, right? And then if we come to the right-hand side, we have 1 sodium, we have 1 chlorine, we have 2 hydrogens, we have 3 oxygens, and then we have 1 carbon. So the carbons are balanced, the oxygens are balanced. What we need to balance are the sodium atoms and the hydrogen atoms, right? So let's start with the sodium. Now over here we have 2 sodium atoms. So simply what I'm going to do is I'm going to put a 2 here. After that, we're going to come to balancing the hydrogens. So we have 2 hydrogens here. So what we can do is just put a 2 here. Now before moving forward, let's just do a quick check. Our equation should be balanced at this point because nothing else was out of balance. Now over here, we have 2 sodiums. We have 2 sodiums here. We have 2 hydrogens here, and we have 2 hydrogens here. Additionally, we also have 2 chlorines now, and then 2 chlorines as well here. So our equation is fully balanced. Now let's come to our very last equation. Again, if you want to solve it yourself, I know this seems a little bit intimidating, but please try to solve it yourself and then come and let's discuss the solution. So over here, we can start with the easiest way that I see to tackle this equation is that we have 2 iron atoms on the left-hand side and we only have 1 iron atom on the right-hand side. So let's just start by balancing the irons, right? And then let's approach, for example, let's take sulfur. So now over here we have 3 sulfurs, and over here we only have 1. So what I can do is I can balance this by adding a 3 here. That seems to be the simplest way forward. Now what I'm left with is to balance my potassium atoms. Over here I have 6 potassium atoms, but over here I only have 1. So I'm just going to add the coefficient of 6 here. Now let's do a check to see if everything is balanced. Fe, SO, K, oops, that doesn't look much like a K. K and H on the left-hand side. Let's just see, we have 2 irons, we have 3 sulfurs, we have 4 times 3, which is 12 oxygens plus the 6. We have 6 potassiums and we have 6 hydrogens. And if we come to the right-hand side, same order, Fe, S, O, K, and H. So we have 2 irons, we have three sulfurs. Let me just make that a little clearer. 3 sulfurs. And then I have, again, I have 3 times the 4, I have 12 oxygens, plus 3 oxygens here, multiplied by 2, which gives me plus 6. And then potassium's 3 times 2, 6, and also 3 hydrogens. But then you multiply that by 2 and you get 6. So the equation is completely balanced. Now what I tried to do in this video is give you an example of different equations that you can face, right? We looked at combustion equations, we looked at reactions of metals with acid, and then we looked at carbonates with acid. So the easiest way is to always try to see what is the simplest way forward. Don't overcomplicate balancing equations. It seems very challenging when you start it, but it becomes easier with practice. I hope this video was helpful for you, and I'll see you in the next one. Thank you for listening.